Hello everybody, this is Lorenzo Perella for Physics 116 Spring 2020 with Clark Wellman. Today we'll be going over quiz 9, the final quiz, with chapter 27 Wave Optics, number 1, parts A and B. In this part we are given the back side of a narrow slit illuminated with 400 nanometer light. The diffraction pattern coming through the slit is observed on a screen 2 meters away. The distance between the first minima, that is, the dark fringes on either side of the bright central fringe, is 357 nanometers. We need to find the length of the slit, the width of the slit. To do this, first we have to do it by hand, and then we'll verify it using this hyperlink, which leads to a simulation of such experiment. Now, to do this, we have to first know that we have to use a formula. And the formula in this case is that d times sine theta is equal to m of the wavelength. D in this case is the width of the slit that we're looking for. So first we need to resolve it for d, which is m wavelength over sine theta. Now we're given that since it's the first minima, we know that m is 1, the order of magnitude. So we know the numerator, but we need now to find the denominator, which is sine. Now to do that, we have to make a triangle where here is where the light's being shown, and here is the screen 2 meters away. Distance between here and here is 357 nanometers. Then we make a right triangle. Using sine, we have opposite and tangent, and we find that by the hypotenuse, 2 squared plus 0.357 meters squared, and we get the square root of 4.127449. We put that into the inverse of sine, and we are left with 10.12 degrees. When we take 400 nanometers, which is 400 times 10 to the minus 9, divided by such value, you get 2.276 e minus 6 meters, or 2,276 meters. Now to verify this, we use the Walter hyperlink. Now as you can see, what we did is change the wavelength to 400 nanometers, which gives us a nice bright purple light, and that the width of the slit is 2276. And we can find that the minima right here is 10.1, which equals the same sine value that we got before, therefore allowing us proof that our calculations are dead on. Now the reason that when it comes to this kind of single wave of light, is that there's a monochromatic light passing through the single slit, and that central maxima and many smaller dimmer maximas on either side. So what you're seeing in the middle is the maximum amount of light that does so, and that they vary out at each interval of the wavelength over the distance of the width of the slit, and it does so in a sine curve out in each direction. Okay. Thank you. This has been Lorenzo Perella for Physics 116, Clark Wellman's class. I will have the rest of the videos for my quizzes soon. Until then, have a wonderful day. And take care.